Hello, mathematicians. Welcome to lesson 1.7, Midpoint. We're going to start, as always, doing some warm-up problems. We have two simple problems in front of you right now. The first one is going to be a basic algebra problem. Just go ahead and solve for x. And then the second one is going to be finding the length of line segment RT. Okay, remember what we did last class, finding the distance, right? 2 points on a graph. The word length here is really just a synonym for distance. So actually you can read this question saying find the distance of line segment RT, right? Length, distance, pretty much the same thing. So go ahead and pause the video and then we'll check your work as soon as you are done. Okay, so let's go ahead and check how we did it on the warm-up problems. Start with the first one. First one is just basic algebra to solve for x. So we have a 5x plus 2. I'll go back over here. Okay, so we have 5x plus 2 equals 3x plus 6 equals 3x plus 6. All right, we'll go ahead and combine like terms. You can pick whatever you'd like to do. I'm going to start with 3x. That looks good to me. So we will subtract 3x from both sides, just like that. 5x minus 3x is 2x plus 2 equals 3x minus 3x cancel out to 0. So we're left with 6, just the remaining 6. Next, we will subtract 2 from both sides in an effort to get that x closer to being by itself. So we have 2x, 2 minus 2 cancels out to 0. We are left with 6 minus 2, which is 4. And then lastly, to get that x by itself, we will divide both sides by 2. 2's cancel out, so we're left with x equals 4 divided by 2 is 2. And so in the end, x equals 2. That's it. Okay, let's go ahead and do the second one here, which is finding the length, or aka distance, of line segment RT. R is 3, 4, and T is 7, 2. So we'll go ahead and let's write that down. So R is 3, 4. R is 3, 4. And then we have T is 7, 2. So T is 7, 2. Okay. Now you can draw a graph if you want to solve it that way and use Pythagorean theorem, but we'll go ahead and just use distance formula here because it's a little more versatile. So we have d equals the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Okay, now if you remember from the last lesson, I always recommend that you label everything so you don't accidentally switch numbers and get the wrong answer after so much hard work. So we'll go ahead and label point R, let's see, x1, y1, and then over on T, we will label that x2, y2, and then we will use these to plug into our distance formula. So we'll start with x2. x2 is 7. So we'll do 7 minus x1, which is 3, all squared, plus y2 is 2, minus y1, which is 4, and then all squared. Okay, next we have 7 minus 3 is 4, so we have 4 squared, plus 2 minus 4 is negative 2, so negative 2 squared equals 4 squared. 4 times 4 is 16, plus negative 2 times negative 2 is a positive 4. And so really this is just a square root of 16 plus 4 is 20. Okay. From here we should probably plug this into a calculator. So square root of 20, we'll clear this out. So we have the square root of 20, and that is going to give us 4.47 equals 4.47, just like that. Okay, so the distance between those 2 points, whether they are on a graph or not, is going to be 4.47 units. Okay, very good. So let's go ahead and move on to the lesson. Remember, there's tutoring every day after school except Friday at 3:45 in room 100. You do not have to stay the whole time. You can walk in with a single question, get it answered, and then leave. Totally up to you. This is going to be lesson 1.7, and we are going to be dealing with what is called midpoint. Midpoint. Okay, the learning target for today is going to be that students can find the midpoints and bisect line segments. So I have the same image here that I had during the last lesson because the applications for finding the midpoint of two locations or 2 points are going to be very similar to those of figuring out the overall distance between 2 points. So I use the same image here, except I added this orange midpoint line just to show you what a midpoint is. Just like the word implies, midpoint really means middle point or halfway point between two other points. It's like the middle, right? And that is all we're going to be dealing with today, the midpoint on a graph. Now we'll go ahead and go to the vocab for today. We do have the 4 words. Midpoint, bisect, equidistant, we'll actually deal with this lesson instead of the last lesson, and then a segment bisector. So go ahead and take a second to write all this stuff down and pause the video. Okay, so let's start to go over all these words. We will start with the main word of the day, which is midpoint. Very simply defined as the point halfway between 2 endpoints of a segment. So when we go over here, we can just draw a little picture. Oh, actually, let's go ahead and copy and paste this, right? So we'll then copy and paste. So it's a little more visual for everyone. Okay. So midpoint, so we'll draw a line segment kind of like this. We'll call that A and B. And so the midpoint is just going to be a point that's halfway or in the middle between 2 points. And oftentimes we'll call that point M, just to show that there's, a point in the middle there. It doesn't have to be point M, but sometimes you'll see something like point M to show that it's a midpoint. Okay. Now, just like the definition implied, and like the word implies, this is important because when we have a point directly in the middle, we suddenly have 2 equal halves of our line segment. So line segment AM and line segment MB are going to be congruent, or the exact same thing, right? So this point right here that separates the line segment into 2 equal parts, or 2 congruent parts, is going to be the midpoint. Okay, next we'll go down to bisect. If you look at the word bisect, you see the prefix bi means 2, right? And the etymology sect means to cut or to separate. Okay, if you ever heard the term second or sector or section or anything like that, it usually means to cut or to put together or separate into smaller pieces, right? So to bisect something is to separate it into 2 congruent segments or 2 equal parts. And so when we go back here, we can draw something like, I don't know, maybe something like this, where we have 2 segments, or we'll call those just 2 lines, not 2 segments. And we can bisect something like line JK with this line directly in the middle. So let's say that was the midpoint right there. This line is bisecting line JK. It's straight in the middle. It's cutting it in half, right? I know it's a little hard to picture because my lines are not totally straight because I'm using a Jamboard, but the concept still stands. This line in the middle is bisecting line JK, right? It's cutting it into two equal parts. Okay, and that is pretty much the same thing as segment bisector, by the way. I'm not going to really draw a picture for that. But the segment bisector is going to be this line. This line is bisecting the other line, and it is a segment bisector. Bisector. Okay, that thing's a bisector. So the definition for segment bisector is just any point line, segment, or plane that bisects a segment, just like we were talking about. It doesn't have to be a line that cuts it in half. It could be a point or a plane or something like that. Okay. The last one we have not talked about is equidistant. We know that the prefix equi means equal or same, and distance is distance. So something that is equidistant is something like a point that is the same distance from two other points, at least two other points. And so when we go back to the images here, if we have points that are equidistant, let's say we have that same line segment AB that's on top. And we have point M in the middle. This point right here is going to be equidistant from A and B, meaning it's the same distance from both A and B. For instance, the midpoint, or point M, can be something like 4 units away from A, but it's also going to be 4 units away from B. It is equidistant from A and B. Okay, so that's all that is, and that's all of the definitions that we're going over today. Okay, with that, let's go ahead and go down to our first example. Again, I'm going to call these baby problems because we're going to baby step our way into the content and start learning about midpoint on a number line. Okay, very simple here. So what is the midpoint of xz? So we'll go ahead and copy this picture, go over to Jamboard. Just like that. Okay. So all we're going to do is basically just count and see where the midpoint is going to be. You can do this any way you'd like right now. You can try to use your fingers, or you can draw it out like I am. But we're going to try to find the midway point, or the halfway point between x and z. So we have, we'll go 1 and 1, 2 and 2, 3 and 3, 4, 4, 5, 5, and so we're going to meet in the middle here, so 5.5 and 5.5. Okay, so the midpoint, or the middle of x and z, is actually going to be, it looks like halfway between 2 and 3, so 2.5. Okay, so that is going to be the midpoint between x and z. Now, some of you might have noticed that you probably don't want to count every time, because counting leads you open to error and things like that, counting error. So you can accidentally misplace your finger and get a wrong count. So there's actually faster ways of thinking about this. So for instance, how much distance or length is there between x and z? Well, if x is at -3 and z is at 8, the distance between those, 8 plus 3 plus 8, is going to be 11. So the whole thing here is going to be 11. All right, well, what's half of 11? What's halfway from 11? Well, half of 11 is going to be 5.5, or 5.5, right? So then what is 8 minus 5.5? Or what is -3 plus 5.5? Well, in both cases, it's going to be 2.5, or 2.5. So you can think about it that way. Sort of an easier, faster way to figure out what a midpoint is to get the distance between the 2 points, cut it in half, and then add it or subtract it from your points to figure out where the midpoint is. Okay, you don't have to do all that counting, which is nice. So keep that in mind as we move forward. But with that, how about you go ahead and practice and find the midpoint of each of these 3 segments right here. Okay, pause the video and check your work when you, and unpause it when you're done. Okay, so let's go ahead and check our work here. So we have JP, so the distance between JP, -7 and 5. 7 plus 5 is 12, so there is 12 between JP. And if you don't believe me, you can always count, right? But -7 to +5 should be a distance of 12. So what is half of 12? Half of 12 is 6. And so if we count 6 up or down from either side, we should be at the midpoint. So 1, 2, 3, 4, 5, 6 is at -1, or 1, 2, 3, 4, 5, 6, which is -1. So the midpoint here is going to be -1 for JP. Next, MP. MP has 1, 2, 3, 4, 5 between M and P. So half of 5 is going to be 2.5. And so if you add 2.5 to 0 here, you end up at, well, 2.5. Or if you subtract it from P, you will still end up at 2.5 there. So the midpoint is going to be 2.5 between M and P. And then lastly, we have JN. J is at -7 and N is at +3. So the distance between -7 and +3 will be 10. Half of 10 is going to be 5. And so you can go 5 in either direction. So from -7, 1, 2, 3, 4, 5, we'll end up at -2. Or from +3, we'll go down 5, 1, 2, 3, 4, 5, and we'll end up at -2. Okay, if I said -3 before, I meant -2. Either way, we're going to end up at -2 as the midpoint. So for JN, we were going to be at -2. Okay, good. So let's go to the next example here. And now we're adding, we're incorporating pictures. So we have George or Jorge, depending on who you are in my class. I have a George that's spelled like this, and I also have a Jorge spelled like this, so go figure. Travels from his school on 38th Street, so 38th Street is down here, skateboard, to the library on 62nd Street. He stops halfway there to take a break. Where does he go and stop to take a break? Well, if he's at 38 and he's traveling to 62, halfway we can see is probably at about 50th Street, right? We have 1, 2, 3, and 1, 2, 3. So to me that looks like it's about 50th Street as the midpoint or the halfway point. Okay, pretty simple, not too bad. Let's move on to a practice problem here for you. And oh no, it's a word problem. But really it's not oh no, right? That just means we have to draw a picture. That's not too bad. I'll give you a few minutes to go ahead and solve for this one, draw a picture, and then unpause the video when you are ready to check your work. Okay, so here we go. We have Calvino's home that is located at the midpoint between Fast Pizza and Pizza Now. I'm gonna call this Pizza 1 and Pizza 2 just to keep it simple, right? I don't know why both names have the word pizza in them. It just kind of makes it confusing. So I'll call it Pizza 1 and Pizza 2. Okay, well, Pizza 1 is a quarter-mile away from Calvino's home. How far is Pizza 2 from Calvino's home? How far apart are the two pizza places? Okay, well, let's draw a picture here. So we know Calvino's home is located at the midpoint between Pizza Place 1 and 2. So we'll go back here, and we will draw a line. And again, we know that Calvino's home, well, let's call that point C, is halfway between Pizza Place 1 and Pizza Place 2. Okay. Pizza Place 1 is a quarter-mile away from Calvino's home. Okay, so P1 is a quarter-mile away from point C. So quarter mile is 0.25 miles or 1/4. It doesn't matter. Either way is good. Then we go back. Then it says, how far away is Pizza Place 2 from his home? So how far away is Pizza Place 2 from his home? Well, again, we know that C is the midpoint, right? C is the midpoint. Meaning, if this is directly in the middle between P1 and P2, that means they're going to have the same distances, right? So if P1 is a quarter mile from his house, that means pizza place 2 is also a quarter mile from his house because he's in the halfway point. So the distance here is also going to be 0.25 miles or a quarter mile away. Okay. Lastly, how far apart are the two pizza places? Well, from P1 to P2, we have 0.25, 0.25, or a quarter mile and a quarter mile. So when you add them together, you're going to get a half a mile or 0.5 miles. Right? Either one of those is correct. Either one of those works. Okay, and that's the gist of that. Very good. Okay, so let's actually get to the big boy stuff here. And we're going to talk about midpoint on a graph. Now, we have a big scary formula here that really isn't that scary, especially if you understand the concept of midpoint, right? So what we've been doing before on the number line is we would count, the entire distance between both points. -7 and 3 means there's a distance of 10 there. And then we would just, cut it in half and then add or subtract from either side, right? So half of 10 would be 5, and then we subtract 5 from the other number, and we get our midpoint. Well, that's all this midpoint formula is saying. We're just going to add the numbers together, take half of it, or divide by 2, and that's going to give us the midpoint. Very easy, right? So here's a mini example down here of what we're dealing with. We have point 4, 1, and we have point 10, 5. We want to find the midpoint, or the halfway point, between those 2 points. Okay? Well, just like we were doing earlier, we'll just go ahead and start by adding the x's together. So we have 4 plus 10, which is 14, right? Then we take half of that, which is 7, and that's our midpoint. It's going to be 7. So this point here is going to be 7. And then we will do the same thing for the y's. So we add the y's together. 1 plus 5 is 6. Divide that by 2, or take half of it, and that will be 3. And then the y coordinate will be a 3. And that is it. That's our answer. The midpoint is 7, 3. We just add the x's together, divide by 2, add the y's together, divide by 2, and we are done. So if you count on the graph to make sure 7, 3 is accurate, we have 1, 2, 3, 4, 5, 6, 7, which is good. And then 1, 2, 3 up here. Yeah, so 7, 3 does look to be the midpoint between 4, 1 and 10, 5. So if you feel like you're a little behind right now and don't quite get conceptually what's going on, just try to stick with the midpoint formula, and that will not steer you wrong. Okay. If you don't need the midpoint formula to solve these, that's totally fine. More power to you. As long as you get the concept, it does not matter if you use the formula or not. Now that being said, we have a couple problems later on where it might come in handy for you. But for now, let's go ahead and just do whatever you're comfortable with. So with that, I think I'm going to skip this example 3 for sake of time and have you go straight to these two problems here, where I just want you to find the midpoint between both of these endpoints. Okay? Go ahead and pause the video and unpause it when you want to check your work. Okay, so let's go ahead and solve these two problems. So we'll start with A. We have two endpoints, and I'm going to draw them out over here. So we have 7, -5. And then we have 3, 3. We want to find the midpoint between those two. Okay. Well, if we want to use our formula, we can use our formula. So that's going to be, let's see, x1 plus x2 over 2, comma, y1 plus y2 over 2. And we'll just plug everything in. x1 is going to be 7. So we have 7 plus x2, which is going to be 3. So plus 3 over 2, comma, y1 is going to be negative 5. So we have negative 5 plus y2, which over here will be 3 again. So plus 3 all over 2. Okay. 7 plus 3 is 10. So we really have 10 and then over 2, comma. Negative 5 plus 3 is a negative 2. So we have negative 2 over 2. And then lastly, let's just divide. 10 divided by 2 is 5, and negative 2 divided by 2 is negative 1. And so in the end, our midpoint, our x comma y value is going to be 5 comma negative 1. Okay? And that is all there is to that. If you just knew to go ahead and add the x's together and divide by 2 without having to use the formula, again, that's fantastic. You do you. That works. Just make sure you get the accurate answer in the end. In fact, let's go ahead and do the second one, and we'll complete it quickly using that method. So we have a 7 comma 0 as our first point, and then for our second point, we have 2 comma 4. 2 comma 4. Okay. Well, 7 plus 2 is going to be 9, so we have 9 over 2. And 0 plus 4 is going to be 4, so 4 over 2. 9 over 2, or half of 9, is going to be 4.5, 4.5, comma, 4 divided by 2 is 2. And that is all. Okay, so it's very helpful if you get the concept. You can just kind of add them together and divide by 2 or half them. It goes by a little quicker than using the formula, but do whatever is most comfortable to you. Okay, whatever is more comfortable. Alrighty, so let's move it up a level here. And so let me show you something. So let's see. Let's go back here and just to kind of recap. What we've done so far is they give us 2 endpoints. They give us, in this case, 4 comma 1 and 10 comma 5. And we want to find the midpoint, or the halfway point, between those 2 points. What we're going to be doing next is actually they're going to give us the midpoint already. So they're going to tell us the midpoint is 7 comma 3, for instance. And they're going to tell us that one endpoint is going to be 10 comma 5. But now this endpoint over here is going to be missing, and we have to solve to find it. Okay? So sort of they're kind of giving us the answer, and we're working our way backwards to figure out what we should have been given to begin with. Okay? And so let's go ahead and do an example reflecting that. Let me go ahead and steal this, put it on Jamboard. Let's see. All right. So this one is saying that we want to find the coordinates of Q, of a point Q, if R is the midpoint. Okay, so they give us the midpoint here. So R is the midpoint of QS, and S has coordinates of 12, 4. So one endpoint is 12, 4. So just to quickly draw that on a graph on a very rough scale here, very rough scale. They're saying that S is at 12 comma 4, so something like over here. They're saying that R is the midpoint, so R is going to be something like right here. And they're telling us to figure out the coordinates of Q, which is going to be somewhere over here. Okay? So we know what S is, we know what R is, and we're trying to figure out what Q is. And that's what we're doing here, okay? All right, so this is how I would solve these problems, a little methodical. So I'm going to start by drawing out the midpoint formula. So midpoint equals x1 plus x2 over 2, comma y1 plus y2 over 2. And then from here, I would just go ahead and plug everything in that we already know about. So for instance, M, the midpoint, what is the midpoint? Well, it tells us that the midpoint is 6 comma negative 1. So we'll just go ahead and plug that midpoint in for m, the midpoint. Okay, equals x1. So what are we going to plug in for x1 now? Well, it tells us that the endpoint we do know is 12 comma 4. So for x1, we'll plug in 12. What about x2? What are we going to plug in for x2? Well, remember, we are trying to figure out the coordinates of Q, the other endpoint, right? So we don't actually know what x2 is yet. That's what we're trying to find. That's going to be the answer. And so we're actually going to leave that as x2. And then we'll just continue on and just divide that by 2. Comma y1, we will plug 4 in for y1, plus y2, which again we are trying to find. That's going to be the answer. So we will keep it as y2 all over 2. Okay. Now here is the important part. What I would do is I would then separate or chunk our equation here into the x components and the y components. Okay, this is what I mean. So I'm going to draw a big X here just so we know that we're dealing with x. My pen messed up, so excuse that X. But let's start with the left side here. So what component of this midpoint has x in it? Well, that's going to be 6, right? 6 is the x component of our coordinate here. So we have 6 for the x equals, and then what is the x component of this side of the equation? Well, that's going to be this side here with x2, right? So we're going to write 12 plus x2 over 2. Now from here, we'll just go ahead and solve for x2. What we want to do to get x2 by itself first is probably get rid of that divided by 2. So let's multiply both sides by 2, like that. And so 2 times 6 is going to be 12, which equals, those cross out, and we're left with 12 plus x2. Last thing to get x2 by itself is to subtract the 12 away to the other side. Okay, so we have 0 equals 0, but we'll cancel that one out. And then x2. And so in the end, x2 is going to equal 0. Okay, so 1 down, 1 to go. Let's practice that again with, or by finding the y component. So we'll do a big y here to remind us we're dealing with y. And then the y component of the midpoint is now going to be -1, like that. The y component of the right side of the equation is going to be this part with y2. So 4 plus y2 or over 2. Okay, and just like with the x stuff, we want to get y2 by itself, so we will start by multiplying both sides by 2. So -1 times 2 is going to be -2, which equals, those two cancels out. We're left with 4 plus y2. Lastly, we will subtract 4 from both sides. And so we're left with -6 equals, those cancel out, y2. Okay, and there we have it. So we now have x2 is 0 and y2 is -6. And so our final answer, right, the end point, the x comma y value that q is, right, we're trying to find q, is going to be 0, let's draw that a little bit better, 0 comma -6. So this is going to be our endpoint q. So this is what q equals right here. And that is our answer at long last. Okay? All right, so let's go back and go ahead and do an example on your own. You can just go ahead and do A. You can do both if you want, but I'm just going to go over A. So go ahead and pause the video, do your best here at A, and then we'll go over the solution when you're done. Okay, so let's go ahead and find our missing endpoint here. So it says find the coordinates of the missing endpoint if B is the midpoint of AC. So this B right here, -3, 1, is going to be our midpoint, and then A and C are going to be our endpoints. So let's go ahead and draw that. So A is 1, 7, and B is going to be -3, 1, 1. All right, and we'll figure out what C is. So we want to draw the midpoint formula. So M equals x1 plus x2 over 2, comma, y1 plus y2 over 2. Okay, let's go ahead and start plugging everything in. They already told us that B is the midpoint, right? It says the missing endpoint if B is the midpoint, so B is the midpoint. So we're going to plug that in for M, so that's going to be -3, 1 equals x1, we'll call that one 1, we'll see x1, y1, we'll label them. So x1 is going to be 1 plus x2, which we're trying to find, over 2, comma, y1, we'll say is 7, plus y2, which we're trying to find, all over 2. Okay. Now from here we will go ahead and we will separate the x's and the y's. So we'll draw a big X here to remind ourselves. The x component of the midpoint is going to be -3, which equals the x component over here, which is 1 plus x2 over 2. To get x by itself, we will multiply both sides by 2. So -3 times 2 will be -6, which equals 2's cancel out. We're left with 1 plus x2. Then we will then subtract 1 from both sides. So in the end, we have -7 equals x2. All right. Let's go ahead and do the y's now. So we'll do y's here. So the y component of the midpoint is 1, which equals the y component over there, which is 7 plus y2 over 2. I'll go ahead and multiply both sides by 2. So 1 times 2 is 2, which equals 2's cancel out. And we are then going to just have 7 plus y2. And in the end, we'll subtract 7 from both sides. And so we'll have 2 minus 7 as -5, which equals y2. There we go. So in the end, our final answer is going to be x comma y, or -7 comma -5. And that is going to be our missing endpoint. C. All right. All right. So the last thing that is really present here is just finding the measures of line segments here, knowing that knowing where the midpoint is. Now we've done stuff like this before. In I think a couple lessons ago we did. So I don't think I'm going to spend too much time. I'll probably just do the example here, and I won't have you do any, but feel free to practice. So for this one here, let's see. Let's go ahead and copy it over to Jamboard. Okay. Bam. Okay. So it says find the measure of line segment RT if T is the midpoint of RQ. So if T is in the middle, right, by definition, if T is in the middle, it wants us to find what RT is, okay? Well, since T is in the middle, we know that RT and TQ are going to be congruent or the same, right? If this thing is splitting RQ directly in the middle, that means it's bisecting it or splitting it into two equal halves. And so really, if we know that RT equals TQ, or these two segments equal each other, are the same thing, right? We can just write that out algebraically. So that means 2x plus 3 RT is going to be the same as or equal to TQ, which is equal to 4x minus 5. And so this is where that warm-up problem comes in. We're just going to then solve for x and call it a day. So we'll go ahead and, let's see, subtract 2x from both sides. So those cancel out. So we're left with 3 equals 4x minus 2x is 2x minus 5. All right, we will add 5 to both sides to get x more by itself. So then we have 8 equals 2x. And then lastly, to get x by itself, we will divide both sides by 2. 2's cancel out, so we're left with 4 equals x, or x equals 4. Okay. Now, that's all fine and good. X does equal 4, but just keep in mind what it wanted to begin with. It said find the measure of RT. All right, well, we know RT is 2x plus 3, so all we're going to do is just then plug it back in, right? So we have 2x plus 3. When we plug x in, we then have 2 times 4 plus 3. 2 times 4 is 8, and then plus 3. So in the end, the length of RT is going to be 11. And that should be correct. If you ever want to check your work, you could, of course, always plug 4 in for the x over here for TQ. And when you do that, you will also get 11, therefore confirming that both halves are the same, and that t is the midpoint. Okay? And that's pretty much it. I'm going to skip the practice because I think you guys get it. You're just going to set them equal to each other, right, because it's halfway in the middle. And so let's go to the homework. If you're honors, you can go ahead and do this one if you would like. And then see homework. Okay, so all the homework is listed here. We have 1 through 11 odd, which sounds like a lot, but a lot of that is, hey, what's the midpoint of between 1 and 3? It's pretty low-level stuff, in my opinion, anyway. Then we have 17, 19, 23, 33, 35, 43, and 45 for the homework. Okay. Remember, these solutions are in the back of the book. And that's to help you out so you can check your work. And turn in your homework on time, turn in your notes, and I will catch you next time. Take care.